Greetings everybody. On September 7th of 2023, Dr. Barker found a closed form expression to the infinite series that you can see here. I put the link in the description to his video, and I just managed to figure out an alternative approach to this problem which I would like to share with you. Using series notation, we can write this expression as the infinite series where k runs from 0 to infinity of x raised to the 4k divided by 4k factorial. And it's not hard to notice that if we differentiate this function 4 times, it actually gets back to itself. The first derivative is the infinite series as k runs from 0 to infinity of 4k times x raised to the 4k minus 1 divided by 4k factorial. And since the zeroth term of this series is 0, we can actually start k at 1. And this also simplifies to the infinite series where k runs from 1 to infinity of x to the 4k minus 1 divided by 4k minus 1 factorial. And if we differentiate this 3 more times using consecutive application of power rule, we get the fourth derivative as the infinite series where k runs from 0 to infinity of 4k minus 1 times 4k minus 2 times 4k minus 3 times x raised to the 4k minus 4 divided by 4k minus 1 factorial. And we can write 4k minus 1 factorial as the product of 4k minus 1, 4k minus 2, 4k minus 3 times 4k minus 4 factorial. And sorry, here k starts at 1. So we can simplify the top and the bottom as 1 over 4k minus 4 factorial. So we get the infinite series as k runs from 1 to infinity of x raised to the 4k minus 4 divided by 4k minus 4 factorial. And here we can do an index shift. So if we want k to start at 0 in the summand, we have to replace k by k plus 1. And this gives us the fourth derivative as the infinite series where k starts from 0 to infinity of x to the 4k divided by 4k factorial, which is the original function y. So we have the fourth derivative of y equals to y, or the fourth derivative of y minus y is equal to 0, which is a very simple, linear, homogeneous, constant coefficient, fourth order ODE. The characteristic equation for this ODE is simply r to the fourth minus 1. And if we solve that for the roots, we can simply factor this as r minus 1 times r plus 1 times r squared plus 1, the roots of which are plus minus 1 and plus minus I. So we can write the general solution to y as c1 e to the x plus c2 e to the negative x, and these two solutions correspond to the values of plus minus 1 for r, and then the solutions corresponding to plus and minus I are linear combination of sine and cosine of x. So we can write c3 times sine x plus c4 times cosine of x. So here we have four constants of integration, c1 through c4. And to find those, we need to use some initial conditions, which are simply the value of y and its derivatives up to the third order at x equal to 0. So we're also going to need to differentiate this expression 3 times and get 4 equations for the 4 unknowns, c1 through c4. The first derivative is c1 e to the x minus c2 e to the negative x plus c3 cosine of x minus c4 sine of x. The second derivative is, if I copy and paste this and do the proper modifications for y double prime, we get c1 e to the x plus c2 e to the negative x minus c3 sine of x minus c4 cosine of x. And the third derivative will be close and very similar to the first derivative. So I'm going to copy that, and we get c1 e to the x minus c2 e to the negative x minus c3 cosine of x plus c4 sine of x. Okay, so now we can get the 4 equations that we need for these 4 constants. Y at 0, if we plug 0 into y for the value of x, we get y of 0 equal to c1 plus c2 plus c4, and that's equal to 1. Y prime at 0 is c1 minus c2 plus c3, and that's equal to 0. Y double prime at 0 is c1 plus c2 minus c4 equal to 0, and y triple prime at 0 is c1 minus c2 minus c3, which is also 0. So here we get a simple system of linear equations, 4 equations, 4 unknowns. And to solve that, I just get some help from the software. Oh my, sorry about that. So the matrix of coefficients are 1, 1, 0, 1. The second row is 1, negative 1, 1, 0. The third row is 1, 1, 0, negative 1. And the fourth row is 1, negative 1, negative 1, and 0. And the right hand side vector is 1, 0, 0, 0. So we notice that C1 and C2 are 0.25 or a quarter, C3 is 0, and C4 is 0.5. So C1 equals to C2 equals a quarter, C3 is 0, and C4 is half. Plugging these values for these 4 constants gives us the final solution. So we get y as I can factor out the quarter from the first 2 terms, e to the x plus e to the negative x, c3 is 0 and c4 is half, so we get half of cosine of x from the last term. And here I can change this 4 to 2 and divide stuff inside brackets by 2. And now inside the brackets we have cos of x. We can factor out the half from these 2 terms, and we get half multiplied by the quantity cos of x plus cosine of x. And that's a good place to stop. Thank you for watching.